Good day, MedTech students. Welcome to my last lecture in laboratory management. Today, we will discuss laboratory design and workflow. This topic provides information about laboratory design elements and guidelines or guidance to help define the issues to be considered when designing a clinical laboratory. Learning outcomes for this topic includes discussion of laboratory design and its relation to workflow, identify different factors in laboratory design for optimum functioning, recognize different stages in workflow and laboratory design, sketch laboratory floor layout based on the government's guidelines, and to summarize the lecture, here is the topic outline. We will start with the introduction and end up with laboratory floor layout. To begin this topic, laboratory design is the planning and design of the physical and structural relationships of work and the workplace. It is a significant fulfillment of the planning and organizing management function. The advent of automation and instrument has permitted performance of more procedure in smaller space. It has a greatest influence in laboratory productivity. Thus, a good understanding of laboratory design issues that affect space, workflow, cabinetry, equipment, ventilation, lighting, plumbing, electrical, and data is important to enable personnel to work easily and efficiently responding to technological and procedural change. According to the Health Facilities and Services Regulatory Bureau of the Department of Health, there are several classifications of clinical laboratory. Number one classification is by ownership. It, it can be classified either government or non-government. It is a government when it is operated and maintained by the national and local government unit, another political unit or department such as the NBI or the National Bureau of Investigation or the PNP or the Philippine National Police, or they can be private. It is owned, established, and operated by any private individual, corporation, association, and organization. Number two classification is by function. These can be either clinical pathology or anatomic pathology. Clinical pathology includes examinations in clinical chemistry, hematology, immunohematology, microbiology, immunology, clinical microscopy, endocrinology, molecular biology, cytogenetics, toxicology, and therapeutic drug monitoring. While anatomic pathology involves surgical pathology, immunohistopathology, cytology, autopsy, forensic pathology, and molecular pathology. Another classification is by institutional character. They can be institution or freestanding. A laboratory is institution or hospital-based if it is within the premises and as part of an institution, but not limited to hospital, clinic, school, medical facility, birthing home, and drug rehabilitation center. While it is freestanding if the laboratory that does not form any part of an institution. And the last classification is by service capability. They can be general clinical laboratory or special clinical laboratory. The general clinical laboratory is subclassified based on their service capability. Primary laboratory can perform CBC or complete blood count and qualitative platelet count. Also, routine urinalysis and fecalysis. While secondary laboratory performs the duties of the primary lab plus routine clinical chemistry such as glucose determination, blood urea nitrogen or BUN, uric acid, creatinine, and total cholesterol. They can also perform CBC with quantitative platelet count. while the tertiary laboratory performs the secondary and the primary laboratory plus special clinical chemistry such as your liver function test and hormones, or special hematology procedures including coagulation test, immunology and serological test, microbiology, culture and sensitivity of aerobic and anaerobic organisms, and the limited service capability. This is for institution-based laboratory only, where lab tests required for particular service such as in dialysis or social hygiene clinics. And another type of laboratory is special clinical laboratory. This offers highly specialized lab services that are usually not provided by the general clinical laboratory. Example of these are your research laboratories, blood banks, and sperm banks. So, in the laboratory design and workflow, there are three major divisions in the laboratory that must be taken into consideration. Number one is the receiving of specimens that happens in the reception area. The processing of specimens, which involves the different departments and sections in the laboratory, and the releasing of results that is through the LMS or the Laboratory Management System or LIS, Laboratory Information System, or you can do it manually using the releasing section of the lab. Because remember, in the laboratory, you have interface with customers, patients, and other users. So the laboratory must interact in two directions, the intake and the return of information and results. Where intake involves the requisitions of specimens from the patients and from the doctors. This is hard to remedy because majority of the responsibility relies on patients and doctors that is not part of the laboratory, while return of information and results is easy to remedy because most of the personnel that is involved is part of the laboratory and it occurs within the laboratory. There are several factors to consider in laboratory design for optimum functioning. Number one is spatial relationship within the institution. This refers to the distance and physical structures such as walls, halls, and other buildings between two or more areas that must closely interact for the work to be completed. Also, these hinder or expedite the flow of specimens within the laboratory. For example, the distance between the emergency room and the laboratory will lessen the time required for transportation of personnel services between these areas and the laboratory. The next factor is the intra-laboratory relationship. This is the distance between the different sections of the laboratory. The relationship of support services to the processing sections, like the distance of the outpatient department to the phlebotomy area, to the hematology, clinical chemistry, and blood bank department, or the distance of the receiving area for urine to clinical microscopy and microbiology must also taken into account. These can also hinder or expedite the flow of specimen. The third factor is mechanical services. This includes proper ventilation, noise control, which are important to the morale and productivity of the laboratory staff. The fourth factor is casework and interior design. This includes benches and cabinets. This provides some flexibility for future changes, that is updating of machines and instruments. The fifth factor is communications. This includes the telephones with extensions or direct line and intercom or fax machines. It is important that there is an answering service that connects to the different sections of the laboratory. The sixth factor is safety equipment and design, that during the planning stage, laboratory directors should become thoroughly familiar with federal, state, and local safety regulations. And the last factor is the support services. This includes your specimen blood collecting area or your outpatient department, and for blood donors for collecting urine and discharges. Other support services includes your storerooms, wash area, staff facilities, patient facilities, library and conference room, and space for research and development that can affect the work situation in the lab. And in making a laboratory design, there are different stages. Stage one is the planning process. This is a project design team should include both laboratorians and construction specialists, should solicit inputs from pathologists, technical and administrative managers, and other professionals who work in the lab because they will be the end user. Number two is the written narrative description. This includes the FND or the functional narrative document and the schematic drawing of the laboratory. Third phase is budgeting. This includes the capital budget and specific tools and techniques for justifying and preparing a budget for expensive and long-term projects such as building or remodeling of a laboratory. Fourth is graphical displays, includes final working drawings, project manuals, and building models. Also, in laboratory design, development and review process is very important. It is an extensive, detailed package covering all aspects of the workflow and project design. This is intended to give the architect a comprehensive overview of the purposes, functions, and needs of the user and provide the information needed to prepare the initial schematic design drawings to the facilities. And there are three phases involved. Phase 1 is the laboratory responsibility. This is the writing of the FND or the functional narrative document. It is a document prepared by the project design team to describe the purpose, functions, relationships, and activities that will be conducted in an area, with the specific goal of providing architects and engineers with the information needed to prepare the formal plans and construction agreements. Also, the preparation of initial schematic drawings, the descriptive title given to the first attempt of the architects to interpret the information of FND or the functional narrative document. It is usually straightforward single-line drawings that outline the various areas of the project. For example, this is the illustration of the schematic diagram, which shows the division of the floor area in various departments and sections of the laboratory. Phase 2 is architectural and engineering responsibility. This is design development drawings, a preliminary floor plan or blueprint. Draft includes construction details and layout patterns, structural features and requirements, utilities and plumbing placement, ventilations and airflow plans, and building codes and regulation compliance. This includes full-scale model of the project as well as line drawings. And part of the phase 2 also includes the final working drawings, where the final blueprints that will be used for the construction of the project, and once final agreement has been obtained from all parties, the architects complete the working drawings or blueprints. And phase 2 will end at the making of the project manual or the construction guidelines proposal. This is a document that contains the working drawings and detailed information of the type of building material and construction techniques to be used, informally called as the spec book. So once the spec book is done and the agreement of the owner and the contractor will phase 3 or construction will commence when they agree to each other. So the functional narrative document or FND contains the following information: the type of task and movements in the laboratory, the volume of the activities, structural needs of the test or procedures, kinds of instruments and their specifications, the communication links, the number of personnel and the staffing patterns, the supply requirements, and the detailed descriptions of the computer system or the LIS, the laboratory information system, including the wiring, the location of the central processing unit and terminals, as well as the outside linkage. So to prepare for the FND, information must be gathered through spatial relationship. If a sample must travel down 2 halls or pass through several other sections before being delivered, this spatial relationship must be planned into the workflow and design of the laboratory. Also, making of the bubble drawings. This is a series of circles that represent a function or area and depict the flow of information and work task by using lines and arrows to show the direction and connections of the relationship. So this is an example of a bubble drawing made of circles. It shows the relationships between various areas and departments in the project or design. Also, the making of block and schematic drawings, it must be prepared in the FND. These are preliminary floor plans or sketches representing the first efforts of the architect to put the functional narrative document on paper. So this is an example of your block and schematic diagram. So it shows the different parts of the laboratory equipments as well as the vision of the sections in the lab. Another sections in the laboratory or the FND, another section in FND is relationship matrix or the department relationship matrix. It is a matrix for illustrating and defining how each section or function interacts with each other areas. So this is an example of the relationship matrix. This shows the relationship of each sections where solid circles represent strong or very important relationship, outlined circle is important, and square is ordinary or no relationship at all. Or another example for department relationship matrix is this one, where it is being legend or represented by numerals 0 to 2, where 0 represents no or ordinary relationship, 1 is important relationship, and 2 is very important relationship to each other or to each department. And the last is building models. This may be a lifelike built to scale replicas or color-coded blocks that represent people, counters, furniture, and instrument. So you can either use a recyclable materials or computer program for the building of models. So this is an example of a computer-generated model of a laboratory showing its division, furnitures, and equipments. So last part of the discussion is how to lay out the laboratory floor plan. So before laying out, you have to take note of the basic floor plan requirements according to the Health Facilities and Services Regulating Bureau or Regulatory Bureau of the Department of Health. For the primary laboratory, you must have a minimum of 10 square meters in the floor area. This is the total floor area of the laboratory. Access to toilet. You have an area for clinical work with sink and pathologist area. For the secondary laboratory, you must have a minimum of 20 square meters in the floor area, a toilet, a clinical work area with sink, and a pathologist area. And for the tertiary laboratories, they must have a minimum of 60 square meters in the total floor area, provision for toilet, clinical work area with sink, pathologist area, and microbiology room. Also, please take note of the major consideration on layouting of the laboratory floor plan. So, clinical laboratory shall conform to all applicable local and national regulations for construction, renovation, maintenance, and repair of clinical laboratory. The laboratory shall conform to the required space of for the conduct of its activities. There shall be well-ventilated, lighted, clean, safe, and functional areas based on services provided. There shall be a program of proper maintenance and monitoring of physical plant and facilities. There shall be procedures for proposal disposal of waste and hazardous substances. And the last, there shall be policy guidelines on laboratory biosafety and biosecurity. So this diagram shows the floor plan of the laboratory with specimen movement as represented by lines. So this is a floor plan plus the movement of the specimen. Also, another example of the floor plan with movement is this. It is represented by arrows. The specimen flow is represented by arrows. And that concludes my discussion for this afternoon. And don't forget to read the references given to you to supplement your understanding and answer the activity that will be posted in the Google Classroom. And before I end up this discussion, I would like to take this opportunity to thank all of you for giving me a chance to be your mentor, and also congratulations for finishing lab management in a very short period of time. And always remember that teachers open the door, but you must enter by yourself. You can have access to professors and teachers from the best schools in the world, but you still need to be willing to do your work even when it's hard. I know it puts so much pressure to you, and majority of it comes from me, and I apologize for that, but please do realize that I am doing it for your own good. I believe in your intellectual as well as your emotional capacity to do to overcome this pressure and to pursue your dreams as part of the healthcare providers, or to be a good healthcare provider in the near future. God bless all of you and see you as colleagues. No goodbyes because our paths will cross somewhere and in different times. Good day, everyone, and keep safe always.